Well, hello tech enthusiast, and in our today's video we will be discussing about the various techniques and types and algorithms used in this vast field of AI/ML, and like this video could be the most helpful video for you, so don't forget to like, share and subscribe to this video. So let us first start with the very basic question that what is AI and ML and where are they used in the real world problems. AI stands for artificial intelligence and ML stands for machine learning. They both are closely related fields that are revolutionizing the way we interact with computers. AI. In a big picture, AI is a broader field of computer science concerned with creating the intelligent machines that can think and act like humans. Yeah, like for real. This can include things like understanding language, recognizing objects, learning from experience, and solving problems. Think of it as building smart machines that can mimic human cognitive abilities. And whereas machine learning is a subfield of AI, machine learning is a specific technique used to achieve AI. It allows computers to learn without being explicitly programmed. By analyzing data, machine can identify patterns and improve their performance on specific tasks. Think of it as teaching machines to learn from data on its own. And whereas the real world problems are concerned, AIML are used for a wide range of real world applications because they can automate tasks, make data driven decisions, improve accuracy and efficiency. They can handle the respective task more efficiently and accurately than humans, and freeing humans up for more complex works. And they can be used as a recommendation system, fraud detection, and in medical diagnosis or self-driving cars and all the like more innovative applications. Let's start. So the main tree in the up, and the first thing that comes when we say about the machine learning is supervised learning. Supervised learning is, let me write it too, supervised learning. Let's make it a little smaller. Yes. So first we will see the all types of learning or all types of techniques, then we will head towards their meaning and understanding. And the second is unsupervised learning. As the name suggests, it is unsupervised. Yeah, we will look later what is supervised and unsupervised means. So for now we will adjust it a little more. Okay. And the third one is reinforcement learning. We will again discuss everything in detail, what are these things and how it is used and how it is been like trained and all. Okay, so these three, and there are more like semi-supervised learning, which is a mixture of supervised and unsupervised learning. So yeah, wait a sec. Okay, I guess I should make it in the middle. Okay. And then comes the deep learning part, where we deal with the neural networks, and deep learning is also divided into multiple parts. We will also discuss them too. Deep learning, yeah, this should be, I guess, bigger because it contains lots of things inside it. And then comes the transfer learning. Should I add it over here? Okay, transfer learning. Let me make it a little shorter. Okay, yeah. And there are like still there are so much like instant based learning and meta learning. Wait, let me just add them quickly. Instant base and meta learning. uh, okay, so there are yet many fields, but these are the main ones, right? Okay, so let me quickly add them out. uh, okay, just a sec. Okay, so these are the typically fields that divides the AML. And yeah, so let us start with the supervised learning. This is a category of machine learning where the algorithm learns from the data that is already labeled. The data includes both input, has an image or any type of like input, and the corresponding desired output, like labeled output. If an image of a cat, it would be labeled as a cat. By analyzing many examples, the algorithm learns to map the input to the correct output. Like imagine a situation where you have a bunch of emails labeled as a spam or not spam. Supervised learning algorithm can analyze these emails and learn to identify on its own in new emails. Yeah, so supervised learning is categorized into like three main things like regression, classification, and ranking. To understand regression, it's basically like predicts a continuous value like house price or weather forecast. Imagine trying to guess an exact temperature tomorrow, 32 degrees Celsius or around, based on past data. This is called a regression where the values are dependent and it predicts on the values. So, and the second thing is classification. sorts data into categories like spam or not spam email. Imagine you have a bunch of email labeled as a spam or not spam. A supervised learning algorithm can analyze these emails and learn to identify the spam on it or in new email. Supervised learning is also based on the ranking, orders items based on preferences like movie recommendation or search results, image, ranking your favorite movies from best to worst. This all comes under the supervised learning, and this is so far the supervised learning. And moving ahead to the unsupervised learning, unlike the supervised learning, unsupervised learning deals with the data that has no predefined labels. The algorithm has to find the pattern and structure within the data on its own. This can be useful for the task like customer segmentation, grouping the customers with similar characteristics, or anomaly detection, identifying the unusual patterns if someone alters the data or something like that. For instance, unsupervised learning can be used to group customers based on their purchase history without needing to label the each customer segments. Yeah, so to see the examples, unsupervised learning can be roughly divided into the four types that are clustering, dimensionality detection. It sounds very like hard, but yeah, it's basically easy. And anomaly detection, association, rule learning. Okay, so starting with the clustering, groups similar data points together, like grouping customers with similar purchase history. And dimensionality reduction simplifies complex data by reducing the numbers of features variables, which we call, while keeping the important information. Imagine summarizing a long document into a short key points. Like most of the LLM uses this type of approaches. And anomaly detection identifies an unusual pattern in the data, like detecting frauded credit cards. Association rule learning discovers relationship between the items in data, like finding the products frequently bought together at stores. Imagine noticing that people who buys peanut butter often buys jellies too, so we can identify in such a way. And these all type belongs to unsupervised learning. And then we proceed towards the reinforcement learning, which is more like a human based approach. This is type of learning where the algorithm interacts with the environment and learns through the trial and error process. It receives a reward for the desired action and penalties for the undesired ones. Over time, the algorithm learns to take actions that maximizes its rewards. It's human based in such a way that if a human does a good thing, we can give him a reward, and if a human hasn't haven't done a good thing, he will get a penalty. And over time it would be like more based on the rewards, and we would improve the efficiency of the algorithm. For an easy example, I would say a dog learns with actions, example sitting, and gets reward in terms of treat, and adjusts its behavior accordingly. And if dog misbehaves, we will be punishing him or giving a penalty, and it would improve and adjust itself. And so far what reinforcement learning is all about. And moving and semi supervised learning is basically a mixture of supervised learning and unsupervised learning. Now let us see what is deep learning. It is a subset of machine learning that focuses on building and training a neural network with multiple layers, hence the term we use deep. It involves the use of complex algorithms and architectures inspired by the structure and function of human brain to learn from large amount of data. So first thing, like it is roughly divided into five parts, which are CNN, RNN, GAN, and autoencoders and transformers. So let us start with the very first one, CNN. CNN stands for convolutional neural network. It's particularly good to recognizing the patterns in an image and video. Imagine recording objects in a pictures by breaking it down into the smaller sections and analyzing them individually. It is basically used in image detection or video detection or something like that. So it comes under the deep learning part. And second thing, RNN stands for recurrent neural network. It can handle the sequential data like text or speech. This process information considering its order, like understanding the meaning of sentence based on the order of the words. So it's basically used in a LLM models. GAN stands for Generative Adversarial Network. In this, we basically have two neural networks. One which generates images or which generates new data in form of images or musics, and one tries to distinguish between real data and generated data. So basically, it's more like a human approach where one is creating new things and another one is criticizing on that new thing, whether it is new or it is already generated or already used one, and such as competing with each other in the generating and distinguishing each other. This improves over time, creating ever more realistic output. So to state it, or it is mostly used in a Gen AI approach, which we say Gen AI. Gen AI is basically based on generative adversarial network itself. So it is more like important parts. So now let us proceed towards the encoders. in neural networks that learns to compress the data and then recreate it. So encoder is basically compressing itself and then recreating itself. They can be used for dimensionality reduction or anomaly detection, as we discussed before, by identifying the data that cannot be accurately reconstructed. Imagine creating a compressed version of an image and still captures its essence. Yeah, something like that, like very on surface level. And then we come to the transformer, the heart of the LM models, a specific type of neural network architecture excelling at neural language processing task. They can analyze the relationship between the words in sentences and perform the task like translation or text summarization and such high level tasks. It's basically an architecture form of sort of thing. And then we come to the fifth part, which is transfer learning. Transfer learning is basically reusing of the knowledge gained from the pre-trained model on a new task. Like imagine training a dog to identify a specific breed, then using that knowledge as a base to teach to identify the other breeds. This saves time and resources compared to the training from scratch. Now we move towards the instant based learning. It basically depends on making the predictions based on the similarity of new data to the existing data. And the algorithm we use is k nearest neighbor, a classic instant based learning algorithm. It classifies new data based on the labels of it. Imagine classifying an animal picture based on the most similar picture in a labeled dataset. And now moving towards the most good, or I can say the most efficient AIML field, which is meta learning. Meta learning, the goal is to develop an algorithm that can automatically learn how to learn new tasks or domains more efficiently. Meta learning algorithm aims to acquire the knowledge or meta knowledge from the past experiences and use it to adapt a new task quickly. Yeah, so that's so far the whole AML field is concerned with. And there are some more topics like embedding learning and like one shot learning and Frederates learning, but they are not often used, so we will not cover in this video.